welcome back to Quick Concepts. This is for Math 87. We're going to be talking about factors and divisibility today. First of all, what is a factor? So a factor is any whole number that divides into another number evenly. And that means no remainder. Okay, so let's talk about factors. So if we were going to list all the whole factors of 12, we would say 1 and 12 because 1 times 12 is 12. Then we would say 2 and 6 because 2 times 6 is 12. And then we would say 3 and 4 because 3 times 4 is 12. So these are the factors of 12. So let's do one a little bit more difficult. Let's say 51. Well, 1 and 51 will always be that, right? But you can't divide it in half. How do I know I can't divide it in half? Well, if a number divides evenly, and I'm going to put these down here, these are some rules. A number can be divided evenly by 2 if the last digit is even. So right away, looking at 51, 1 is not an even number, so I know that no 2 goes into it. But 3, it can happen. How? Well, if the sum of the digits can be divided by 3. So if we were to add 5 plus 1, that's 6. Well, 6 is divisible by 3. So I'd have to figure out, well, how many times does 3 go into 51? And this goes in one time. And lo and behold, it does work out. So the factors of 51 are going to be 1, 3, 17, and 51. So let's keep going with our list here. How do we know if a number can be divided by 4? Well, first of all, if the last 2 digits can be divided by 4, it's divisible by 4. So let's try that. So if I were to say, what about 216? Well, the last 2 digits can be divided by 4. 16 divided by 4 is 4. So let's see if this works out. 4 goes into that 5 times. And it is true. So that's how to tell if it can be divided by 4. Let's try 5. It can be divided by 5. And this, again, these are the rules. Let me write this down. This is the rules of divisibility. Okay, so 5, it's if the last digit of the number is a 0 or a 5. All right, what about 6? 6 is if the number can be divided by 2 and 3. Okay? 7, unfortunately, there's not a rule. 8 there is. This is if the last 3 digits can be divided by 8. Okay, and then 9. 9 is if the sum of the digits can be divided by 9. Okay, so those are your rules for divisibility. That's going to help you out just to kind of do things a little bit quicker. So let's talk about some problems you might see in your book. Why don't we find the greatest common factor, not greatest common multiple, that's something too. The greatest common factor of 18 and 30. So I'm going to just write out their factors first. 1 and 18, 2 and 9, 3 and 6. I think that's it. 30 is 1 and 30, 2 and 15, 3 and 10, and 5 and 6. So what's the greatest common factor? It's going to be 6. Okay. And then let's try one more. Which whole numbers from 1 through 10 are divisors of 9,060? So this is going to allow us to use that those rules we have. So first of all, we know 1 can go into it without a doubt. 1 goes into everything. So we got to decide if 2 can go into it. So again, our rule says 2 if the last digit's even. Well, it's a 0, so 2 can go into it. 3 can go into it if the sum of the digits can be divided by 3. 9 plus 0 plus 6 is 15, so that works. 4 if the last 2 digits can be divided by 4, so 4 can go into 60 15 times, so that works. 5 if the last digit is 0 or 5, so that works out. Did I do the 10 on there? I didn't do 10. This is 10 if the last digit is 0. So I know 10 can. What about 6? So 6 is going to be if the number can be divided by 2 and 3. It can be divided in half, can be divided by 3. 7, we don't have a rule. 8 will not work, and 9 will not work, so it's going to be 10. And that is it.